Hey everyone, welcome back to the Hygiene Hustle. Thanks for the feedback I've had from last time's episode. It's been really well received. It's really nice to get feedback from you guys out there and to get a little bit of the feel for how the rest of the podcast is going to be taken on. Please keep that up. We are on YouTube. We're now on Apple Podcasts. We are also on Podbean. And we have an email address which is thehygieneHustle@hotmail.com. And also we're on Instagram. So please get following us on there and make sure that you subscribe to everything we've got going. You're listening to us, and please give me feedback. We want this to be exactly what you need it to be. So let us know what you want to see. Let us know what you want to hear about, and we'll try and do what we can. So, last time, episode 1, we talked about hygiene and how to build a cleaning instruction card. And as part of that, we talked about validated cleans. So let's dive into what is a validated clean. Validation's the scientific process of checking that your clean is removing every trace of allergen or bacteria that you're looking for. Saying that in a scientific way, validation is defined as a quantitative assessment of cleaning methods to ensure they are sufficient to minimise the allergen cross-contact to an acceptable level. In short, will what we are doing in our cleaning process actually work to protect our customers? This is deadly serious. Allergen validations are the key part in the food industry now, because if we do get this wrong, we will seriously injure or kill people. And that's not where we want to be. No hygiene person out there, no food production facility out there goes out of their way to hurt people. So let's get this right. Before we start the validation process, there are a few things that need to be considered. These things, they're pretty good. They're kind of prerequisites. These prerequisites stand us in good stead for getting the rest of the things right. So these are: is the equipment we're cleaning fit for use? As part of validation, the equipment choice is very vital to the process, not only from a hygiene point of view, but also from a production point of view. Does the equipment give us a finished product in the way we want it? Does it allow to flex for other finished products if the equipment is there? Is it also easy for engineering to work on? And most importantly to hygiene people, can we clean it? Is it hygienically designed? Following on from that, do we have a cleaning procedure for it, a CIC? As part of that, do we understand where the trap points are? Do we understand how the product interacts with the machinery? So all of those things are all about cleanability. It's all about understanding where dirt ends up. We need to do a hazard analysis. And this is both for the process and for the procedure we're using to clean it. So we need to look at the hygienic design of the equipment. As I've mentioned before, this is where dirt may build up. We need to look at how we reach those parts efficiently. This will form part of our worst case scenario later in the process. And as part of this, a balance needs to be found between the part that is hardest to clean, but also a part that is practically accessible. Hard to clean may mean specialist access equipment is required, but that may mean that this isn't practical for repeated testing. Hazards in the cleaning procedure need to be thought about. This includes concentrations of chemicals, water temperatures, and are there any health and safety concerns for dismantling equipment? All of these things are things that we deal with day to day, but they all need to be part of the validation. Going through the process of the validation, we need to work out what constitutes a pass and how are we measuring our results. This all depends on what you're trying to validate against. If you're in a low risk factory with no allergen risk, this could be as simple as validating to no visible debris. In a high care factory with no allergen risk, this could mean no visible debris and a set limit on bacteria on swabs. For instance, a TVC result of less than 100 colony forming units. If your factory has allergens, then validating against removal of all allergens is key. Even trace amounts on machinery can cross-contaminate product, and as we've seen in the press recently, can cause severe illness and even death. Whatever analytical test we choose needs to be specific, sensitive, representative and reproducible. These key elements mean that the objective of the cleaning and disinfecting programme can be tested completely. Direct sampling methods include swabbing for bacteria, rapid swabs for ATP, rapid lateral flow for allergens, and ELISA testing for allergens. Indirect methods are things such as testing rinse water in CIP systems. Another one of the prerequisites is we need to work out what is the worst case scenario for soiling and how do we simulate that. Determining the worst case means choosing the correct combination of products that form the hardest soil to remove. This could be the strongest adhering soil, highest level of allergens, or the hardest soil to remove. The processing that the food product goes through will also have an impact on the removing of the soiling. This could include things such as the cooking on of proteins in a cooking vessel, the heating of milk, things like that. The worst case scenario could include products that have the longest processing time, the highest temperature, or the amount of time the equipment may sit before it gets cleaned. We all know that we don't necessarily get to hygiene straight away, and this could mean that we have a worst case scenario. Ensuring the worst case scenario means any validation will be as robust as possible and will stand up to any scrutiny. Using false mixes of allergens in order to shorten the validation process is possible, and it ensures all interactions between allergens can be cleaned and validated against. I've used this previously in places where I've been doing validations, and we've almost created a horrible mix to get us through the process. It allows us to apply one mixture of product to a surface. We test the pre-surface to make sure that the allergen is present, and then we test after cleaning to make sure that we've 100% removed all of the allergens that we are stating that we're validating for. Another prerequisite is cleaning procedure. Reviewing the cleaning instruction card and the procedure needing to clean is important, as they form a key part of ensuring everybody knows how to clean that equipment to the right level. Cleaning instruction cards also allow easy recording of the parameters of the clean. Things such as strip downs, key inspection points and the chemicals to be used. What is sometimes missed is the actual concentration of chemicals. So not just a band of concentration. Your chemical supplier may say this should be used at between 3% and 5%. That's great, and it allows for variations across the country in water hardness and various different other things. But actually, what is the worst case scenario will play into this. So having the chemical at the lowest possible concentration. Also, water temperature. This is needed to be recorded, and it generally isn't recorded in a cleaning instruction card. Having the temperature at its lowest and having the concentration at its lowest forms part of the worst case scenario. So following the prerequisites, there's a various amount of steps within the validation. Step 1 is validation protocol. This is the creation of the document that's going to say how you are going to do what you are trying to do. So if the outcome of your piece of work is to come and validate a cleaning procedure on a mixer, this is exactly how you are going to do that. It could even be a little bit more general and be the validation of production equipment in the high care area. That allows you to use the same protocol and test every piece of equipment on the same basis. The protocol document itself should have at least the following elements. The aim of the process. As I've said before, working out what you're trying to do and what you're aiming to look for is key before you start anything. The need to validate individual or groups of products. So Grouping products, as I've said, making that horror mix of all the worst case allergens can help to shorten the process. If there are a wide range of allergens to be validated against, combining them minimises cost of testing and the time taken to validate, which can also mean downtime. The next part of the protocol is the people responsible. People responsible for validation is a wide multidisciplinary team. A team approach will guide it much more efficiently, and with it being multi-departmental, it allows the process to be prioritised in the way that it deserves to be. The team should be including people such as production, engineering, technical, hygiene for sure, and maybe even health and safety. In order to get the priority put onto the validation, the process should have the backing of a member of the senior leadership team, the management team, the board, however your site works. The next part of the protocol is all prerequisites I mentioned before. If you haven't got these in place, then you won't have enough of a preparation ready to go through the protocol. The protocol needs your procedure in detail, your CIC, and all of the information that contains. And then finally, the protocol needs the test methods, how you're going to apply those test methods, and at what sample points of the machinery. Part of the agreeing of sample points is part of your worst case scenario and part of the cleanability and hygienic design of the piece of kit. As I said before, that balance of difficult to access versus easily repeatable needs to be weighed up, and then that's where you choose your sample points. Step 2 is the cleaning process. Following the protocol we've agreed, the cleaning process can be started. At least 3 cleaning trials should be carried out. This is to check that your protocol and your system all work. These 3 trials should be spread across different cleaning teams, seasonal variations, and should be reviewed annually, or if anything changes within your factory. This could be a redesign of equipment, it could be a move of equipment, or it could be something as simple as change of chemical or an upgrade to your hot water system. The third key step as part of the validation is the validation report. You should keep a report on all validation trials. Validation forms a massive part of every major audit, so having to hand the information about what you did, how you did it, and why you did it is critical for both auditors and customers. The report should contain a summary of the objective of the process, a breakdown of the results, any deviations from what you agreed in your protocol, any general conclusions from what you found, good or bad, the approval of the validation, and any points that are key for verification and monitoring in the future. Which leads nicely into step 4, maintaining the validation. Verification is the predefined way of maintaining the validated clean. Again, the scientific way of putting it, verification is defined as the periodic assessment of cleaning methods to confirm that the validated methods are still working. In short, are we still doing what we said we were going to do? And is what we are doing still working to keep our factories clean and safe? Methods such as rapid swabs, ATP swabbing such as this system here, hygiene auditing, and hygiene operative observations are all ways we can keep on top of our hygiene validation and verification. You probably use these tools already. A lot of people use ATP for monitoring their post-clean standards to make sure that they're removing all the soils. A lot of people do hygiene audits to check that their operatives are doing what they said they were going to do. These are all verification methods of your validated clean. These are all tools in your arsenal that you use already, but you probably already hadn't linked to validation and verification. What can go wrong? We've done our validation, we've got our prerequisites, we've done our protocol, we've worked out all of our risks and hazards, We've created our worst case scenario. We've documented everything we've done. We've got our results. They come back and something's not quite right. So what can go wrong? Absolutely anything. Anything at all can invalidate your verification and your validation. Training of operatives to follow correct cleaning process. If somebody doesn't quite get the way that machines are supposed to be cleaned, then they can miss a bit. They can not quite clean it to the right specification. There may be something in the environment that's new to the factory that causes the validation to fail. Water temperature. We all know that water systems in factories can sometimes be unreliable. Chemical concentration. If you're running from things such as dosatrons, where they're water pressure driven dosing systems, all it takes is for a small dip in water pressure and your cleaning chemical concentration is reduced. That then reduces the power there that you have to clean, and the standard that you've set for your validation may not occur. Allergens. In factories where there's lots of allergens, the interaction between different allergens in your products may make them harder to remove. This is why using the worst case scenario is always the best way to prove your cleaning process. As I said, pretty much anything can ruin a validation. I've been there. I've struggled to validate things in factories that should have validated really easily. All you can do is you can go back, check all of your steps, make sure you've got everything in place to make sure that that validation is repeatable and that you're not missing one of the key factors that you need to control. And then try again. And if you can't, engage help from a specialist. Don't be afraid of calling in somebody like your chemical supplier who may know some other way of doing a process. I hope that has made the validation and verification step a little bit clearer to you all. That's how I like to look at it. You guys may have different ways of looking at it, and different businesses do things in different ways. I absolutely agree. Please get in contact with me. If you've got something that you think I've missed, let me know. As I said in the run up to this podcast, we've got all these ways of you contacting us. There's the email, there's me on LinkedIn, there's the Instagram, comments on YouTube. Please get in touch with us. Let me know. If I've missed something, I'll hold my hands up, I've missed something. If there's something else you want to see, let me know. I'll try and put it into a future episode. But for now, that's all from me.